Hello, dear students. Today we are going to discuss in details about the chapter remote sensing. Right. So, in the last classes, I have already discussed a little about the remote sensing and remote sensing sensors and its methods. Right. So, today we are going to discuss with the help of these slides what actually is remote sensing. As I had told you, remote means from afar, from a distance that is far, because you can get to know about anything by touching it, by measuring it. Okay, when you are there in your physical capacity, but if you are not in there at that place in the physical capacity, or a place is at a location where it is not physically possible to commit yourself or to go there and take the measurements about it, and also the physical methods are a time taking and lengthy processes, and they have several set of obstruction. For example, if you consider chaining, so in places where there are too many forests, there are plants, then chaining becomes very difficult. In places where there is a, you can say there's an obstacle like a river or like a pond, then the linear measurement method that become inaccessible. So what do? You take these measurements by a system which allows you to overcome these obstacles, and that system allows you to take the measurements from a distance that is far from the entire location or the exact location where you want to take the measurements from. So at those places are the remote places, and what you do is you do remote sensing. That is, the remote sensing is the science and art of obtaining information about an object, an area, or a phenomena like weather, like temperature. It can be anything, and that analysis by the data acquired over a period of time again and again, and this is elaborated, this is understood, this is applied, and you see the final result as an end user. Then this whole system or this whole process is your remote sensing process or a remote sensing system. Right. So remote sensing basically is the science of obtaining and interpreting information from a distance using sensors that are not in physical contact with the object being observed. This definition was given by Randall Smith in 2001. Right. So this is how you define remote sensing. So as we had discussed, what is the actual principle of the remote sensing methods or remote sensing systems component? There is a target. The target is the place or the object about which you have to get the studies of, get the measurement of, right? That is the target. Then you will need an energy source. An energy source can be a passive source or can be an active source, dependent upon how illuminate it gets, or how much it can illuminate the object, and the time and frequency with which it can illuminate a certain object. For example, just like your eyes are also a remote sensing system. What you are doing is you are not actually going and touching anything, but you are still able to make out what is exactly in front of your eyes. So that is also a remote sensing system, but for that you still need the object to be illuminated. For example, if there is a night condition and there is absolutely dark in a room, you won't be able to see what is in the front of your eyes, which you can see when there is a source available. So any target can only be identified by a sensor when there is a source of illumination available, right? Or it is transmitting or it is emitting some sort of energy. So sensors can do that. By naked eye you cannot observe that there's a heated object in the front of you unless you see it. But there are sensors which work on different type of waves and different types of waves of electromagnetic spectrum, which can ultimately help you to identify what type of object it is, what color it is, what shape it is, and different things about this object. So you need a target, then you need an energy source, then you need a transmission path where the waves are traveling, or where you can see that the path between the target and sensor is that transmission path, and basically after that you need a sensor, because the sensor will sense whatever is coming out of the target object, right? This is the basic principle. As I explained, target, the object or material that is being studied. Energy source, it illuminates or provides electromagnetic energy to the target. The energy interacts with the target depending upon the properties of the target and the radiation, and will act as a medium for transmitting information from the target to the sensors, right? What are sensors? Sensors are the basic remote device that will collect and record the electromagnetic radiation. Whatever the radiation, whatever form of radiation is coming back from the target, that is being read by the sensors. As I already told you in the previous classes, there can be a different varieties of sensors sensing different type of electromagnetic waves of the electromagnetic spectrum. For example, a sensor which is designed for reading or receiving the signals in the form of infrared, it may be possible that this sensor does not work in the cases of radio waves, right? So for example, you use a mobile phone that works on a radio waves, right? So if there are other type of waves in the atmosphere, but your sensor that is installed in your mobile is not able to capture all those signals. For example, you have radio stations. So different radio stations have different frequencies, right? What is this? The signal is already in the air, right? Whatever the form of waves the radio signal is carrying with it, that is already in place. But a certain bandwidth is only allowed at a certain sensor, right? So if you are on, for example, you are using 93.5 FM, so you won't be able to listen to 98.3 at the same frequency, right? So there are different waves with different frequency also. Different wave have different wavelengths also. So a sensor can make use of different type of wavelengths, different type of frequency, right? And different type of sensors can read and receive different type of waves, right? So this is how the sensors work. And then these sensors, it can be interpreted. Obviously, if you are receiving some sort of data, you have to interpret it first into a meaningful information. Then only you will be use it as an application, right? So application is your last step. That is, after you receive a data from an object, then only that data is interpreted by interpreting devices, for example, like your GIS and all. And after that only, that interpreted data which has now become a useful information is then supplied to the end users. For example, you receive the location of different points on your mobiles, right? So that doesn't mean that the signal is directly coming from the satellite to your mobile. It is obviously going to a monitoring station, and from there it is formulated and it is analyzed, and then that filtered data which has become now a useful information, that data is conveyed to you, right? So you are being able to use the data which has been processed only, right? So this is the interpretation part of it. How it works, like I said, that there is an energy source. Energy source can be passive or active. A passive source is the one which is dependent upon natural source of energy. For example, sun is our ultimate natural source of energy. So if a certain type of remote sensing system is using the natural energy coming from the sun for interpretation of different type of objects, different type of data, then that system is a passive sensor. And what an active sensor is, active sensor, the sensor in itself becomes the source of illumination, the source of energy. So if a sensor is illuminating, or if a sensor is emitting, for example, you use that in the lab that I showed you, that we have got electronic distance measurement instrument that is based on infrared. Your total station is has an EDM installed in itself, so it is using the infrared radiation, right? So your total station is not requiring the natural source for collecting the information. It is actually working as an active sensor. It is emitting that infrared radiation from its own self, right? So total station or electronic distance measurement, these are working as an active sensor. They are sensing also, and they are also the source of illumination or the source of the waves. But For example, your eyes are also a remote sensing system, but your eyes are not working, your eye do not emit anything, right? Your eyes can see or read anything that has been illuminated by a source of energy. That source of energy can be sun, or that can source of energy can be an artificial source of energy also. For example, you have a bulbs in place, you have CFLs in place, and that is illuminating the ultimate object. So what is happening is that the energy source, it might be passive, it might be active, that energy source is emitting the energy from its own self. This energy is from the passive source or from the active source. For example, in the figure given here, you can see that the sun is acting as a passive source and the satellite is acting as an active source. The satellite is transmitting the signals also. That signals are get onto the object and then are reflected back to the satellite, and then satellite, according to the wavelength, according to the frequency, it reads the data and then interprets the data and then gives you the meaningful information. And the sun, for example, the sun is a passive source of energy that is transmitting the electromagnetic spectrum to the earth. Then there is an atmosphere. All these radiations, all these wavelengths, all these frequency, all these things interfere with the atmosphere. So the atmosphere is one of the most important segment. You have to understand that different type of wavelength, different type of rays coming from the sun or the electromagnetic spectrum, different type of waves behave differently when they come into the contact with the earth's atmosphere. A few wavelengths are stopped at the outer of the earth's atmosphere. A few wavelengths cross there and are absorbed at the lower portion of the atmosphere. For example, the spectrum of ultraviolet radiation, UV radiation, that spectrum is usually I am saying because a certain portion of ultraviolet spectrum do get to the earth's surface, and that is causing so many of skin diseases. But a major portion of the ultraviolet radiation, which is very harmful for the body, very harmful for the skin, is absorbed by an active layer of ozone which is surrounding the earth's atmosphere, right? So different type of wavelengths are absorbed or scattered or transmitted differently and behave differently on interaction with different type of earth's atmospheric strata, right? Then a certain portion get received on the target, and what happens is this target, from this target, it is either absorbed or it is transmitted back or it is reflected back, and that receives the recording devices. What happens next is the transmission, reception, processing. This data is interpreted in interpretation step, and then the final application, which is applicable for all the users, right? What next is we are familiarizing with different types of remote sensing system which are being used currently. For example, not only for acquiring the information of the earth's surface or forest or objects or boundaries, land boundaries, water boundaries, temperature. Not only this, but remote sensing systems are also used in the active medical researches, right? For example, magnetic resonance imaging. You have often come across the term MRI, sonogram, all these things, X-rays, body X-rays, all these things are using different types of radiation, different types of waves for studying the human body also. So human body, the inside of the human body you cannot touch or you cannot directly see with your naked eye. So if there is a problem within your body, then you have to see it from the inside, and that is not possible by naked eye. That is, the visible spectrum of the light do not allow you to see the internal organs, right? So you have to resort to different other type of waves which can help you study the internal organs, right? So those X-rays and those MRIs and those sonograms, these things are using the remote sensing techniques for the studying different type of internal organs of the body, right? So this is your in medical use also. Remote sensing, it is also not limited on the use of our own planet. For example, we know that there is a certain planet called Saturn. It has a moon called Titan, and that Titan has an atmosphere which has 95% nitrogen. How do we know that? Have we been to Titan, or have we been to Saturn also? No. But what we are doing is that we are using a remote sensing technology. The interaction of different type of wavelength with the atmosphere of different heavenly bodies or different planets, that tells you what type of atmosphere is there on a certain planet, what type of surface is there on the certain planet or certain extraterrestrial object, right? So remote sensing is just not limited to the investigation on our own planet, it is also concerned with the investigation of different type of activities on other type of extraterrestrial objects, right? Astronomers collect data, this information is recorded and used to draw conclusion about space and universe that I told you, right? What are other examples? The ocean, beneath the ocean, we are also studying with the help of remote sensing. We cannot reach there every time, so we are using remote sensing technology. We are using magnetic resonance imaging, MRI. We are using PET. We are using space probes. All these things are the different types of remote sensing applications actually, right? What is the history of remote sensing? The remote sensing starts with the invention of camera. Camera is also a form of remote sensing. You are not basically touching the object, but you are getting an image of the object. That is also a remote sensing. Your camera basically works on the visible spectrum of the electromagnetic spectrum, right? And the cameras were formed, and further pigeons were used for remote sensing. Then in World Wars, we used cameras mounted on aircrafts, right, to observe the position of the forces from different countries for military uses. Also, the remote sensing were used, and that use started back in the World War First, right? After that, you can see that there are remote sensing systems which work on the ground. There are remote sensing system. For example, if you take a tower which is like 40-meter high and install a camera over it, or for example you see that your signals now have camera installed over it, that is also a type of remote sensing. But that remote sensing is ground based technique. This is ground based. When the height do not cross 50 meter or more, then you can say that it is a ground based remote sensing method. Then there is airborne, and then there is spaceborne, right? For example, the height of is 50, more than 50 meter, less than 1500 kilometer. For example, there are different type of satellites. Few satellites are polar satellites, and few satellites are geosynchronous satellites, geostationary satellites. So different type of satellites are there in the space in using different orbit. So airborne system can be like if you install a camera on for example an aircraft or in a drone, then that is an airborne system, but that works in the lower space only. But then you have the satellite based system which are as high as 36,000 kilometers. For example, your geostationary satellites are orbiting above 36,000 kilometers, and your polar satellites are about 1500 kilometers. So what actually happens is you have ground based remote sensing methods, and then you have airborne methods, and then you have spaceborne methods. Okay. This is the little basic about the history of remote sensing. We don't want to dwell into it. In India, the satellite, the first satellite of India, Aryabhat, was launched in April 1975. But the satellite are launched using satellite launching vehicle, and before 2000 and something we didn't have our indigenous satellite launching vehicles. Then after that we developed PSLV and GSLV for launching our own satellite. Now you know that ISRO is launching other countries' satellite also. But initially, in the initial days of India's space exploration and India's satellite program, we were using the technology which were used by USSR. That is, the systems of satellite launching that were developed by USSR, we were using that only, right? Camera, Rohini satellites, all these satellites are now being launched by ISRO, and you must have read somewhere, or you have heard about it, that India launched 104 satellites back to back. So that is the record. So now Indian space research system technology has developed to that extent that we are launching other countries' satellites, right? But initially it was not like that. Initially we were using the USSR, the Russian systems, which for launching our own satellites, right? So this is the brief history of Indian remote sensing. It is located at Bangalore, tracking and monitoring. Then there is National Remote Sensing Center, which is in Hyderabad, that processes data, right? So now as type of remote sensing sensor, I already discussed passive sensors and active sensors, right? There are passive systems and there are active systems, right? What are passive systems? The sun provides a very convenient source of energy for remote sensing. The sun's energy is either reflected or absorbed and then re-emitted, right? We had already discussed that the sun's energy is reflected. Reflected means the energy is not absorbed and it is reflected back from where it was coming. If we have got a good reflector, for example, like water bodies like pond, there is a good reflection, and then there is a surface which is rough, which is non-uniform. Then what happens is the light coming from the sun gets scattered. Okay, the reflection is scattered reflection, and then there are few surfaces which absorb. For example, a moon. What happens is that the passive energy that is coming from the sun is absorbed by moon, and that energy is re-emitted at the night time, right? So that is also a system. A passive system can only, but this system, as I told you, that since these are passive system, the illumination is provided by a natural source of energy, that is sun. Then when the sun is not present in the sky due to its position or movement, right, in its own orbit, then what happens is that the source of energy is not available, then you cannot see or do anything as part of your remote sensing, and that is where the active systems come into play, right? So if there is no reflected energy available from the sun at night, then it cannot be detected, right? And then there are active system. The sensor emits radiation which is directed towards the target to be investigated. The radiation reflected from the target is detected and measured by the sensor. What are its advantages? Its advantages are that the ability to obtain measurements anytime, regardless of the time of day or season, right? At any time you can study, no matter if there is a sun in the sky, no matter if there are clouds in the sky, the higher wavelength of the electromagnetic spectrum which these sensors are using do cross the Earth's detraction, for example, clouds, for example, smoke. The radar technology, the LIDAR technology, all these technologies are based on this system only. For example, if these technologies were based on visible system, our aircraft and our airborne vehicles would crash immediately, because at the night time you cannot see anything in the atmosphere, right? Because of the smoke, because of your clouds. So the radar cannot escape the cloud and radar do pass. The longer the wavelength, the higher possibility of it crossing the interactions of the atmosphere, right? Remote sensing platform, as I discussed, there are ground level remote sensing. Ground level remote sensors are very close to the ground. They are basically used to develop and calibrate sensors for different features on the earth's surface only. Aerial remote sensing, low altitude and high altitude, like a drone which is like 100 or 200 meter above in the sky, then that is a low altitude aerial remote sensing. And a polar satellite, for example, 500 to 400 to 1500 kilometer, that can be in a high altitude aerial remote sensing system. Then there are space bound system, for example, space shuttles. There are polar orbiting satellite and geostationary satellite. From each of these platforms, remote sensing can be done either in passive or active mode. Right? So you can see here the different type of altitude and what you use doing. Handheld pole camera, this is a ground based. Balloon, this is also ground based. Helicopter, it is a airborne system. Aeroplane, low altitude, medium altitude, high altitude. Then there is satellite obviously over it. So these are the remote sensing platforms. Now we move on to what an ideal remote sensing system looks like. An ideal remote sensing, all these things that we have discussed up to now, all these things summarized in an ideal way makes up an ideal remote sensing system. For example, an ideal remote sensing system would require a uniform energy source that may be either an active source or maybe passive source, which provides energy over all wavelength at a constant, known and high level of output. Right? For example, a certain object re-emits the energy, right? But this energy that a certain object is re-emitting is not as sufficient to be captured by a sensor. Then even if this object is re-emitting the absorbed energy, it is of no use, because the energy output is so low that it cannot be read by the sensor. So a uniform energy source will have to make sure that a constant, a known and a high level of output is present at every time, at every space, at every location, at every point, right? Then a non-interfering atmosphere which will not modify either the energy transmitted from the source or emitted from the object in any manner. No matter what, if there are interaction with the atmosphere, and due to which the waves which are traveling in a straight path, for example, deflect from its straight path or deflect from its original path, then this is the interference caused by the atmosphere only. For example, there are particles in the atmosphere. For example, oxygen is there, oxygen molecule, for example nitrogen molecule. These molecules can for example, there is smoke, there is clouds. These what are these particles doing? These are these are changing the path of the wavelength or the wave, which either is coming from the source or it is reflected back from the object. So in either case, if a certain wave is diverted from its own position, its original position, then the ground observation that you are getting might be incorrect, or they are either corrected for that interference after knowing what type of interference is that, or it becomes a very tedious process, right? So ideally we will require a non-interfering atmosphere which do not interfere with the direction of the wavelengths and direction of the wave. Next, a series of unique energy matter interaction at the Earth's surface which generate reflected or emitted signal that are selective with respect to wavelength and also unique to each object or Earth's surface feature type, right? So here you can see the sort of flow diagram for an ideal remote sensing system. A uniform energy source from where energy in different wavelengths is coming. Then there is a non-interfering atmosphere which is not changing the path of different waves. Then this energy is reflected and emitted from the object that we have to study, and the sensor receives different type of wavelength, different type of waves, and after that what this sensor do is, this sensor transferred it to a system where data handling can take place. The real time data handling gets place, and then this handled data is interpreted and it is supplied for application purposes to multiple data users, right? So here you can see a super sensor which is highly sensible to all wavelengths, right? A real time handling system you need, which generates the instant radiance versus wavelength response and processes into a interpretable format in real time. Real time as in if we are receiving a signal from the super sensors at this moment, our system should be able to handle it, interpret it and transfer it to multiple data users for application in that instant only. It should not take hours to interpret it. For example, a certain time certain object looked like that. For example, we are using passive sensor. So as the sunlight starts to fade, the color of the object start to change, right? Different type of wavelengths are also start to change. Then हमारा जो वो था उसने अभी तक जो है वो पुराने ही डेटा इंटरप्रेट नहीं कर पाया. So we need a system where the data handling is done in real time, right? And then it is transferred to multiple data users, right? All these we have discussed, the sensors we have discussed, all these we have discussed. Electromagnetic spectrum, based on electromagnetic spectrum there are different type of remote sensing system: optical remote sensing, thermal, microwave, different type of waves and different type of systems. ऑप्टिकल की रेंज कहाँ से है, 300 नैनोमीटर टू 3000 नैनोमीटर. ऑप्टिकल रिमोट सेंसिंग डिवाइसेस ऑपरेट इन द विजिबल और नियर इंफ्रारेड, as I had shown you in the electromagnetic spectrum that I have sent you. The visible spectrum and the near infrared spectrum can be used for optical remote sensing. For example, your camera takes photographs in light, right? So that is a system which is using the visible spectrum of the electromagnetic spectrum, right? Can also use a little infrared also. Most of the remote sensor record the EMR in this range only. ठीक है. Then for temperature we use thermal remote sensing system. So इंफ्रारेड का जो थोड़ा सा मीडियम से हाई पोर्शन है, जो आपका थर्मल इंफ्रारेड का पोर्शन है, दैट पोर्शन यू यूज़ फॉर थर्मल रिमोट सेंसिंग विच इज़ इन द रेंज ऑफ 300 nm to 5000 nm and 8000 nm to 14000 nm. This record the energy emitted from the earth. This is not directly seeing it, but it is working as if it is recording the energy which is emitted from the earth or from the object, right? The previous range is related to high temperature phenomena like forest fire etc. and the later with the general earth feature. अगर general earth feature है तो 8000 से 14000 तक होगा तो चलेगा. अगर वही है ना कि आपका जो थर्मल पोर्शन है इंफ्रारेड का, दैट इज़ नियर द लो पोर्शन ऑफ द इंफ्रारेड. सो दैट पोर्शन ऑफ इंफ्रारेड 3000 to 5000 nm, that is used for cases like forest fire and all that you have to analyze. And then there are microwave system, radar technologies and your phones and all these. These are based on 1 mm to 1 meter wavelength रहती है. ठीक है. Most of the microwave sensor are active sensors, that is they are transmitting their own microwaves, right, having their own sources of energy. That example radar sat. Longer wavelength microwave radiation can penetrate through cloud cover, haze, dust etc. As the longer wavelengths are not susceptible to atmospheric scattering which affect a shorter optical wavelength, this property allows detection of microwave energy under almost all weather and environmental conditions, so that data can be collected at any time, as I told you. Then there is electromagnetic energy. The light travels with a speed of 3 into 10 to the power 8 meter per second. This is carried on in the form of electromagnetic energy, and the electromagnetic wave, you can see that the peak of the electromagnetic, the distance between the two peaks is called wavelength. एक सेकंड में कितनी बार जो है ऐसी पीक्स आ जाती हैं, that will represent the frequency of it. So this is how electromagnetic radiation is radiated from certain object. General process. What is the general process? Source of EM energy, propagation of EM energy, electromagnetic energy through atmosphere, interaction with the atmosphere, retransmission through the atmosphere, recording of the reflected energy by the sensing system, generation of the sensor data in pictorial or digital form. This is the general process, right? All these things you have already studied. This is the electromagnetic spectrum that we are talking about. The shorter, shorter electromagnetic spectrum on the left side and the larger wavelength on the right side, and the visible spectrum that we use to see anything, that is your Vibgyor, that is in the range you can see here, right? So only the visible spectrum is the one where you can actually see an object, right? You cannot see wavelength smaller than that, you cannot see wavelength higher than that, right? So it is only the visible spectrum which is associated with colors and all, right? You can see here, you can write here. If your exams are conducted in multiple choice question, for example corona cases do not come down, then you have to be ready to answer all these questions, because these are the questions which are usually asked in multiple choice question types, right? What are active sensors, what are passive sensors, what are different wavelength, and what are the different bands. Okay, that we will discuss in the further classes. Okay, so we have to stop this video here because the video is getting lengthy. Other type of videos will be updated very soon.